Well, hey there, everybody. It's your boy, Mr. Perry. And here we are, Unit 9, Lesson 1. It's time to talk about inheritance. Let's go ahead and get started. So, one of the questions I like to ask my students before we get into this topic is for them to think about what we have inherited from our own families. So, you feel free to pause the video and answer these questions. Can you identify something you've inherited from your parents? Can you identify something you've inherited from your grandparents or maybe your great-grandparents? And can you identify something that you have inherited from the very first human beings to walk the planet, as in the cave people? So when you think about inheritance, you can think about material things that you've inherited, like objects, like belongings or possessions. But a lot of times we also think about traits, like hair color, eye color, the way we talk, the way we walk. A lot of those things are also inherited. So when we talk about inheritance, in the real world, when we think about inheritance, a lot of times we think about money, like we inherit money, we get something valuable from our parents or from our grandparents. In Java, when we think about inheritance is a lot more like a shortcut. It's a way that you can organize your code so that it's shorter, it's easier to read, it has more layers of abstraction, and it would be easier to scale up and basically just easier to manage in general. And it does a better job of, I think, illustrating the benefit of object-oriented programming. So let's get into what inheritance is. It's one of the fundamental concepts of object-oriented programming in Java. And what it does is it allows what we call a child class or a subclass to inherit properties and behaviors such as the instance variables and the methods from a parent class, or what we can call the superclass. And what this does is this promotes code reuse, and it establishes a nice relationship between classes. Once you start working with inheritance and you start seeing how different classes interact with one another, the whole concept, like the bigger picture of object-oriented programming, might come into view for you if you've had a hard time seeing it so far. So we can think of inheritance kind of like a family tree, where the superclass is just kind of like this generic family member. And the subclasses basically are our family tree, our grandfather, our grandmother, and then of course our mother and our father, and so on and so forth. Typically at the top end of the inheritance hierarchy here, you get more generalized topics, such as family member is a very generalized label here. And then as you go further down, you typically get more specialization. So you get things that are maybe a little bit more specific, like a grandfather and grandmother. And then underneath that might be, mother and father. And then underneath that, you might have siblings. So again, usually at the top end, when you're looking at your superclasses, they are more generalized. And then when you look at your subclasses, they get more specialized. That's typically what you see. So a subclass or a child class, of course, is the class that inherits. And then the superclass or the parent class is the class that is inherited from. And so we'll go ahead and we'll look at an inheritance example here. So you might remember from earlier in class, all classes inherit certain things from the object class. I always say way out in Java cyberspace, there is an object class that is the superclass of basically all classes that are created in Java. Now the object class is very simple. It has an equals method and a toString method. Now if we want to decide to create classes, so let's say I wanted to create kind of an insect world. I might be tempted to make an insect class, and even though the insect class technically inherits from the object class, all classes that we create inherit the same things from the object class. So it's kind of redundant to consider, every class a subclass. So we're just going to go ahead and consider insect as our superclass. Now, I could also create what's called a bumblebee class, which is a little bit more specific. And I could go ahead and make bumblebee a subclass of insect. And then if I wanted to, I could say, well, actually, the queen bumblebee is an even more specific type of bumblebee. So I could go ahead and create the queen class as a subclass of Bumblebee. And if the queen class is a subclass of Bumblebee, that means it is also a subclass of insect. So Bumblebee would inherit from insect. Queen would inherit from both Bumblebee and from insect. So that's just kind of how that works. Now, superclasses, again, are the most abstract and they are the most broad in their scope. And then again, subclasses are the more specific and unique versions of them. So that's typically what you see is, again, very broad and generic labels up here, and then as you go down the inheritance tree, things get more specific or more unique. All right, now let's talk about the benefits of inheritance. So again, code reusability is a big part of it. You don't have to rewrite the same code for every class. The shared logic can be defined in a parent class and then reused. So if I know that there's methods that I want Bumblebee and Queen to use, what I can do is I can just create an insect class that contains those methods and then use inheritance. I can extend the insect class for Bumblebee and then I can extend it again for Queen in order to just reuse those methods and I don't have to rewrite them. It's also gives you improved maintainability. So the changes that you make in the superclass are automatically reflected in the subclasses. And then any new functionalities can be added in the superclass. And then again, the subclasses automatically gain those improvements. So it just helps with the maintenance of the program. Again, any change that I make in insect or any functionality that I add in insect automatically get inherited by these other two subclasses. And then finally, it results in better organization. Inheritance makes a clear structure. So for instance, the vehicle class leading to the car, truck, and bike subclasses. It just makes it easier to understand the relationship between the classes. You can see how certain classes come from other classes, and again, you just kind of get better organization, and typically, you end up with a program that's easier to read and easier to understand how it works. Now, there are some rules about inheritance, and this is important. A class can have many subclasses, but a class can only have one superclass. So I can extend, I can create, from the insect class, I can create a bumblebee class, I can create a butterfly class, I can create a praying mantis class. I can extend the insect class as many times as I want to. But all subclasses only have one superclass or one parent class. Subclasses inherit anything that's labeled public in their superclass, except for the constructor. Subclasses don't automatically inherit the constructor. You have to create a separate constructor for your subclass. But anything else that's labeled as public, so any public method, will be inherited. Now, anything with a private modifier is not inherited, but you can access those things indirectly. And we'll look at how that happens, all right? And then when we get into inheritance, we always talk about what's called an is-a relationship. So one way to just make sure that you're doing it correctly is subclasses have what's called an is-a relationship with the superclass. So in other words, Bumblebee is an insect. So as long as you can say, this subclass is an example of the parent class, then you know you're doing it correctly. And then so again down here, Queen is a bumblebee. Queen also is an insect. So again, that would work. Subclasses always have an is-a relationship, meaning that they are an example of the superclass. All right, so let's look at an example of how this works here. So here we have public class insect. So here is our superclass. And it has a method called crawl, which is going to print crawls on your lap. But then it also calls a method called eat something. And then down here, Eat something is defined as a private method, which just prints out finds food. Now this will be important in a minute here, but the insect class only has one public method called crawl. Now if we look at the bumblebee class, so we'd say public class bumblebee extends insect. That's how you create a subclass from a superclass. You just add the keyword extends. So that means bumblebee automatically gets access to crawl, and bumblebee also gets indirect access to eat something because the public method crawl calls the private method eat something. So the bumblebee class also has a new method called defend hive, because the bumblebee, one of the more specific behaviors it would have separate from the insect class is, perhaps it wants to defend the hive, which means it's just going to print sting the human invader. And then public class queen extends bumblebee. So queen is extending bumblebee and creating a subclass of bumblebee. But remember that because bumblebee extends insect, queen also is inheriting from insect. And what would the queen do that's different from the bumblebees? Well, it might incubate the eggs. So it has its own unique method called incubate eggs, and it's just going to print sits on the bumblebee eggs. So if we go back to this inheritance kind of hierarchy type thing, because crawl is public, and because it calls the eat something method, which is private, bumblebee and queen both access eat something indirectly. The insect class has crawl and eat something. The bumblebee class it inherits crawl, which gives you indirect access to eat something. The bumblebee class also has defend hive. If we go down here to the queen class, the queen inherits crawl as well as that indirect access to eat something. It also inherits defend hive, and it also includes its own unique method, incubate eggs. So that's how inheritance works in a general sense. Hopefully you're getting a better idea of how methods are inherited and which ones are available in which class. All right, and last couple things we're going to talk about is generalization. Generalization and specification. So generalization is, when creating multiple classes for a program, if you notice that they share instance variables and methods in common, then it makes sense to go ahead and create a superclass. So if I was going to create a program to simulate like a fast food restaurant, I might have a burger class, I might have a hot dog class, and I would probably have other, food classes. But then I might notice that, okay, burger has item name and price, as well as has cheese and cook temp. Hot dog also has item name and price, but also has with pickle and is coney. So it might make sense to go ahead and just create a generic class called menu item and give that item name and price, and then extend menu item and create subclasses for burger and for hot dog, because again, you're automatically going to inherit the things that they have in common, and then you can just define the things that are unique. And then I mentioned specialization. So when you want most of the behavior of a parent class, but you want to do it at least one thing differently, and or have more data, that's when you're using what's called specialization. So if we went ahead and made that menu item class, that parent class, then what I can do in my burger class and with my hot dog class is I can just focus on what they have that is unique, the specialization portion. So I could have, with burger sauce and grilled bun as some of my instance variables. Over here, I might add with relish, as again, another instance variable. There's all kinds of different ways that I could modify and specialize the burger class and the hot dog class. now that they are subclasses of menu item. All right. And UMLs it's important to remember UMLs here because UMLs can be a very useful tool for understanding how situations involving inheritance work. So for instance, over here, we actually have 3 different classes that are interacting with one another to, simulate, kind of courses and students and basically simulate sort of a school and educational setting. So down here you have the course class, which has a title and has an array list of student objects. Over here we have our student class, where every student has a name and an ID number. And again, the course class might contain an array list of students who are enrolled in that course. However, I might also create a subclass of the course class called AP course. And that would include maybe the exam date, stored as a string. So with all of these classes that are interacting with one another in this single program, again, it can be a little confusing at times what's doing what. A UML is, again, a good way to, keep all of those things straight. All right, so let's do our lesson review here. A class hierarchy can be developed by putting common attributes and behaviors of related classes into a single class called a superclass. Classes that extend a superclass, which are called subclasses, can draw upon the existing attributes and behaviors of the superclass without having to repeat them in the code. The keyword extends is used to establish an inheritance relationship between a subclass and a superclass. And again, you just add the word extends in the subclass's class header. And remember that a class can extend only one superclass. And then finally, extending a subclass from a superclass creates what's called an is-a relationship from the subclass to the superclass. All right, guys, well, that's it for this video. Thanks for watching. As always, make sure to leave a question or a comment, and I'll see you in class.